record, by the way, because this I think is going to be worthwhile people seeing. Yeah, I hid my black thing over there. All right, try to be in a window here. So with we're about to start talking about functions, and we were just talking about operators last week. And I was just realizing when I ran that they actually had some examples of what I'm calling operators that they're using as conjunctions. So they talked about and they had a train car that had and on it was going to join two things. In one of them, they had some kind of a sample like something and peas and ham, I think it was, or ham and peas. And they had ham, and then they had and. They used this symbol on the actual side of the train. That might remind you of the fact that they had and when we combine two things in C++. Another thing that was kind of subtle, but it happened, is they showed railroad tracks that were going down the middle, and they actually had either go to the mountains or to the sea, and the railroad tracks were down in the middle, and it said either go to the mountains. That's not the pencil. Either said go to the mountains or to the sea. And when they pan the camera basically from here to here, it was mountains on one side and the sea to the other, and the train tracks were like an or. So that was actually very subtle and meant nothing to anybody that was younger watching Conjunction Junction, but the idea of ands and ors. Now they talk about what the function, in other words, what the uses of these words. What we're going to do today is we're going to explore how you use an actual function within a C programming language to do a job. But I wanted to clarify that when I say that we're going to use a function, it doesn't mean the same thing as a conjunction. All right? They're different. We're not just putting things together. And so this is a source here that talks about what you can do in C. Now, I want to see, I'm going to bring up a poll. Has anybody here used a function before in C++? Okay, so I've got 75% of you so far have said no, but I gotta show you something. I just want to point this out to you. Has anybody ever gone in here and made sure that they select their language to C++ up here? Sorry, I was in the way. C++ and done a run. Has anybody ever done that before? And they kind of get this hello world down here? Sure. The way that's happening is this right here is a function. So when you run int main, you're running a function. So if I ask this question again, I would expect that everybody would say, oh yeah, I've used a function. Maybe I did say it wrong. So any function. And this, in fact, is a function. It's a special function with a special name. By the way, I'm going to get rid of any of these extra comments at the top because they're not helpful to us in the sense that, yeah, we can just get rid of that. All right. That one I do need, though. Some people might describe this as the smallest C program in the world, and it actually is a single function. And it works. It prints out hello world. Now, if I wanted to set up this, now what is a function and what do we use a function for and why would we have functions? Does anybody have any ideas? You can either unmute yourself and talk, or you can type it out. Nobody has any ideas why? All right, so let's take a look at another thing we've done in class before, and maybe help take something and bridge it into something new. If there's anyone that has not done the Lightbot activity, it's something that I refer to because it sets down some basics that I want you to be able to understand when you do program. When you're programming without any functions, you basically have to do all of your work in main. So right up here above my head, we have something called main. That might look familiar. And it's got a series of steps in it that the robot will follow. Over here, we're doing something where in main, we have an indication of P1. I'm using the corner of my head there to indicate where I'm pointing. So this P1 is actually saying, start here, follow these steps, and when you're done, return back up here to the next step. That's a function. It's called a procedure there, but it's a function. And another one of the steps that we work on in Lightbot is to get you to understand you can use P1 to maybe loop, to repeat things over and over again, and there's a P2 as well. So the reason that you would set up a P1 or a P2 or a function are all the core same idea. You're going to do it because you've got a set of code you're going to want to do more than once. So when I'm first teaching you about these functions, I'm going to use a very simple idea just to show you how to break up your work into chunks known as functions. But functions typically do a job that is multiple C++ statements. So there's the what we're doing in class, and then there's the how we're going to do it, to learn it. And then there's the what you're going to do to actually have it happen. Have we talked at all about what happens when you run a game before? So have I described, true or false now, have I described the game loop to you? I don't know if I have. I'm thinking most everybody's going to say false here. So the game loop is something that repeats over and over again. Now, since I got my head over here on the screen, I'm going to stop sharing it a second time, and I'll make it a little smaller so hopefully it doesn't lag quite so bad. So if you think about a circle, or if you think about a clock, or basically we're going to repeat something over and over again. Another way to describe this shape would be a loop. And within programming, you are going to repeat a loop over and over again. You might do some things beforehand to set it up, but within a game, you're going to do a number of steps, and these have been drawn out a number of ways. One of them is you're going to take an input from the player. Because if you're not taking input from somebody, then it's not really a game. It's just, you're just playing a movie, basically. So we get the input from the player. And once there's the input from the player, you need to decide, for example, like, what are the what's the result of that? If they press the fire button, what do you need to do? If they press the up arrow, what do you need to do? If they press the jump function, what do you need to do? So you're going to process that input. And as a result of that input, you're either going to, depending on how you've set up your loop, you're either going to process your AI or your other players. I'm just going to put OP for other people, for other players. And then what you need to do once everybody's kind of moving to their new position is you got to figure out, was there any collisions, and deal with any collisions. So if there was a bullet flying through the air, did it hit you? Or did you go to jump and there was something blocking you? So we're going to need to deal with collisions. Some other things that are going on in the game loop that are pretty common would be things like sound effects, particle, and special effects. You need to calculate all those things out, and then you would give people the output. You'd update the screen. Now, this happens repeatedly. Probably happens 120 times a second on most games nowadays. Now, remember, you can't just talk to the computer and say, go invent life. It gets very good at doing things exactly that you can tell it what to do very quickly. So each of these major processes or steps in this game loop is a good candidate for a function. So especially if you want to build more than one game, it might be that processing input's kind of a standard for you. Updating the screen might be a standard. You can reuse it from game to game. one of the ways that we implement this without even using what we call object-oriented programming is to put things into functions. So we want to practice this so that we're familiar with the idea and that we can do it ourselves. So let me do kind of a ridiculous version of a function just to prove a point here. I'm going to break this up to multiple functions. Is there a need to do this? No. But I'm going to do it so that I can show you some concepts on functions. The web page I had up before, which is a great resource for you, talks about the different parts of a function. And in this image right here, this is main, which we've talked about. There's the start of it. There's the end of it. You'll notice there's going to be 3 times that a function is going to show up in a listing or in the code. The first time is up at the top. It's actually called a prototype. You have to tell it what the name of the function is, but you also have to tell it what it's going to return when it's done. So we should touch base briefly on types of data. Because right now, this is showing an integer value is getting returned, and if it works successfully, it returns a 0. So this 0 is of this type integer. Anyone have any questions about how type of data relates to value? Is there any questions on that at all? All right. Right up here before main, I'm going to set up another function. It's going to print the word hello, which seems kind of silly, but I just want to show you how to break something up. So if I type in void, meaning it's not going to return anything, print hello, not going to bring anything out. This is a description, it's called a prototype, of a function that would basically print hello. So now what I'm going to do is I'm going to come down below main, and this is going to be the body of that function. The difference here is up here, the prototype, it's like the table of contents. All it really does is it says coming up later. It doesn't give you all the details. So if you're watching TV and you hear coming up later, SpongeBob, followed by more SpongeBob, followed by more SpongeBob. So every job that you have needs to be declared up at the top with a prototype. And all it's doing is it's saying, when I'm done, this is what I'm going to return. Not what I'm going to output on the screen, but what I'm going to return. This one's going to print the word, it's going to print world. I'm going to set up another one here that's going to go down a line. Not in the current one, but I'm just going to show you how I can add a feature in here. Now, all of these have empty sets of parentheses, and they have a semicolon. All that is at the prototype is a description of what it's going to do. Down below, if I were to say in the below main now, so on line 12, I'm going to add the details or the body of this code. I'm not going to have a semicolon here. I'm going to put any semicolons, any commands inside of a set of braces. And they're going to show up. Any commands I need will show up in here. For example, if I'm going to printf, just a command, the word hello, I've now got a command that will do, or a function that will do that. I no longer will need to print that right here. I can do a function to actually do it. The way that I would do that is I would put the name of it, just like if I call someone's name, like if I said, hey, Edward, I've just called his name. Hopefully I've got his attention. Or if I said, yo, Logan, just called a name. So when you call the name, you're basically invoking that one. It's like when you say P1 in the Lightbot world. So if I say print H, which is an actual function that I can select from my list here, it's a function call. I need to give it that sandwich that can take any input in. In this case, I'm not passing anything in, and I'm not bringing anything out. An empty set of parentheses doesn't have to say void in the middle. It's just understood that it's empty of value. It's empty. So this function will print the word hello. And if I ran this again, it would say hello. There's no spaces in there. Then it would say hello world. So let's try that. And I'll adjust the size of the screen so we can see the output. So the first hello is coming from the function that prints it. The hello world comes from main. You can't tell from the output which one did what. I did spell print W wrong. My camera's right in front of me. Thank you for that catch. I'll come back in here. Okay, so I've got the print W set up. So I've got 3 of them that are coming up later. Now, they're all returning nothing, doing basically the one thing. Print H. Now, if I did another one here that says print W, I don't have the body in here yet. I've got a function that I'm trying to call, but it doesn't have a job. So if I said, oh, there's 2 Jacobs now. It's going to use Jacob, but I can't. Yamato. Does he know what his job is? No, because nothing's been declared here. If I try to do W here and I try to run this now, what happens when it goes to run W? It says, print W. I don't have any details. I don't know what to do. And that's what you're all thinking. Why am I yelling your name out? So in order to give it the details, like this one, these are the detailed instructions. This is called the definition. And so in this area below main here is where we're going to put the definition for a statement. And I want you to follow along with this. I'm going to copy this whole function and paste it because I'm going to do almost exactly the same thing again. Now you might notice that there's what I would call an extra semicolon. Makes kind of a weird looking like mustached winky face guy. That's an extra semicolon that's not going to cause a problem. This one's going to print W, so it's going to be world here. There's no reason that I have to do separate functions other than to show you if I now do print W, this is going to do hello world right next to each other, and then it's going to say hello world from main. So I'm going to go ahead and run this. So now the one that does world knows what it should do. That world gets printed by that function there. What questions do you have about functions so far? Okay. I don't have any spaces in here. So maybe I need another function here that's going to print a space. So I'm going to call it put space. Up space. That camera does get in the way. And put space, so I can put one between them, could be very similar to this, and it would just print a space. Now, it doesn't hurt the program at all. I'm actually losing efficiency, I think, by doing this. Put space. I'm just double checking myself. So instead of print W, it's going to be put space. So put space is just going to put a space in the output, and I can do that as many times as I want to. Here, just one space there. So this, in order to call that, right in between the two, I'm going to put in the call for a put space. It needs to have those braces, or sorry, that like that. So now when I run it, I will get a space between the two words. In fact, I can put print space down here. Remember this parentheses. That's a function call. It's like calling someone's name. In fact, let me just copy and paste this multiple times here. And yes, I know it looks better when they're all individual lines, but what I want to do is just show you that I can have it more than once and it will be fine. So now I should see hello space world space 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 hello world, as long as it compiles. All right, this doesn't look like it's working really well, so I'm going to stop this if I can. There we go. It says undefined reference to put space. I probably typed it wrong. Ah, this is something altogether different. Does anybody notice what's wrong with this one? Because to the computer, a capital S is totally different than a lowercase s. There we go. So now I should be able to run this. By the way, interrupted this whole compiler program getting lost. It's not a problem. You're going to get this message at some point or another. It especially seems to be happening when I've got a few people online. Like right now, we've got 21 people online. So I'm not sure exactly what's causing this, but this is a free system we're using. I'm going to do a stop. If you've got some code here that you want to keep, highlight it all. That's Control A, and do a copy, Control C. Then what you can do is open up something like a notepad. Show it up on my other screen, and paste your code in there. Ugly as it is, that's the code. It doesn't have all the pretty colors on it, but you can actually save your work that way. In fact, I gave you a sample today that's in the Google Classroom. It's just in a Google Doc. You can copy and paste it in here. So since this is kind of not working smoothly for me and I've had it open all day, I'm going to close out of this tab. I'm going to leave it. And I'm going to close out of a couple of these other things I got going on here. And I'll just open a new tab. There we go. Jump into GDB. There's a project right here. I'm just going to start with a new one. Make sure it's C++. Highlight everything and paste it in. There's the code I was working with, and I'm going to try to run this. There's my hello world with my spaces. So even though you might have gone, oh, my connection got lost, it's savable. Save your data, restart a project, paste it back in there. Don't panic. It's okay. All right, so now I've got this broken down so I can continue to take something like hello world and break it into really small pieces by using functions. I'm only doing this to illustrate the idea of functions. Now, what you're going to be doing today in class, and I expect questions. If you don't ask questions, then I'm amazed. If you go into the classroom here, you will see in the class I've got two activities, one from Friday on the if statement and one from today. When you look at that, it's going to describe what I want you to do, and it's going to give you some sample code to start with. So I'm going to grab this sample code here, copy it. You'll actually get it'll divide your screen. You'll see the sample code on one side and the instructions on the other. The big hint here is copy and paste. And remember, each function is going to show up 3 times. So I'm going to go into a new project just so it's easier for me to see what I'm doing. I'm going to highlight the part that's there and paste it in. And I want to do a sample run before I do anything else as a C++ program. So this is a demonstration and sample of a function to modify different values, to basically, for you to modify, I should say. So it's going to show me how to add 2 numbers, and I want you to set up another version of this, your own version, that does subtract, multiply, divide, and find the remainder. And if you got all those things done, I've got a bonus challenge for you in the assignment where you can actually demonstrate what we call increment and decrement. So I'm just trying to make sure nobody's bored here. Everybody's got something to do. So I'm going to try 2 numbers. So I'll try 25 and 32. Just grab 2 numbers. Now what happens is we're taking those 2 values, the number 25 and 32, and we pass them into a function. Big difference between the function we're running now, which we'll look at, and one that was empty that just printed a word, is it's going to bring in 2 values and it's going to add them together. So let me see, can I toggle that off and on? Yes. Let me do this. I'm going to bring open another one of these paintable screen things. And if you were in class learning, remember, computers can only do what you can do. And I said, all right, take 25 and 32, terrible colors, by the way, and add them together. 25 plus 32 equals, you'd say, what, 57? So that's how you would write it out. But in code, what you'd say is, all right, take, we're just going to say return the sum of your first number plus the second number. That's how you say it in code. It's Yoda. Remember, he talks backwards. If he was going to do it a different way, we might say into an integer value called sum, I'd like to add the values of first and second. So there's variable names here. There's an operator. So this is the operator that's actually doing the addition. It's the plus symbol. And I've linked a chart out there so you know what the symbols are to do them. But let's talk briefly about what they are. If you're going to add two numbers, we're going to use plus sign. You're going to subtract, you're going to use a minus sign. Does anyone know what you're going to do for multiply? By the 8 key, shift 8. You know what that's called? Thank you. It's the asterisk. How about divide? How do you do division in C++? What character do we use? Yes. Now, some of these operations are going to be the same no matter what order you do them in. If you multiply or add, it doesn't matter what order they're in. So 3 times 5 is 15. 5 times 3 is 15. But with subtraction, it makes a big difference. So you might want to run these more than once in opposite order to see what the differences are. Heads up on divide. If you divide by 0, it causes a real problem for the computer. It might even crash it. There's one more thing I'm asking you to do, and that is to find the remainder. To do that, you're going to use this operator here. It's called the modulus operator. Deceptively simple, very powerful. And this is all working with integer math with this. So with this put off to the side, I want to do kind of a refresher on what we do when we do long division to figure out a remainder. Do you guys remember long division at all? Let me do it this way. I'm going to clear out statuses. I'll bring up a poll. Who knows how to do long division? It's okay if you don't. A lot of people use a calculator. And some people might be like, what do you mean long division? Long division would be something like, why am I doing it with that? I should just do it with a pencil. All right, so if I've got, not a very thick line. Yeah, we'll stick with this for a minute. So when we set up a long division problem, what we typically do is we'll put a dividend, like 3, for example, divided by 5. How many times does 5 go into 3? 0. 0 times 5 is 0. So 3 take away 0 is 3. What's my remainder? I have a remainder of 3, which is weird to put your head around because it's not a decimal thing. It's just an integer thing. Now, if I did these in the opposite order, where I switch my dividend and my divisor, and I put the 5 here, and I say, how many times does 3 go into 5? Well, then at least once, 1 times 3 is 3, and I take that away, and I end up with a remainder of 2. So the remainder here is 2. Now, there is a way to get the, there's 2 different answers we're after here. One of them is the remainder, and the remainder one comes from using this symbol called modulo. And again, I've got that linked out to show you. I should publish these results. I think those are showing up on the different screen, but they're there. So when we use long division, which the computer can do for us, it'll either bring back the quotient. That's the word I forgot. We got dividend, divisor, and quotient. What questions do you have for me? If you don't know it off the top of your heads, it's okay. It's not something we practice, right? I use a calculator on my phone all the time. Yeah, it's been a long time. So here's the funny thing. If I bring up my calculator here, clack, here it is. So I've got mine set in programmer mode. I'll get back to this in a minute. Let me switch the view back to standard mode for a minute, and I'll resize this so it's not so obnoxious. All right, this is a calculator, and if I do 5 divided by 3, it's going to tell me that the number here is some weird thing. This is a decimal value. It's not an integer value. There's no remainder. This is more accurate, but it also requires dealing with a different type of data. We're going to use whole numbers a surprising number of times in games programming, because when you're dealing with integer math, that's how a screen is. A screen is like 1024 by 768 or 2048 or 4096. All of the resolutions of our monitors are whole numbers. We don't have anything that's in between 2 pixels. So when we're working with our graphics drivers in our art, it's either going to be a 1 or a 2. There is no 1.666666 that goes on forever. Doesn't happen on a screen. In fact, here's a good example of that. If I zoom in enough here, you can start to see that it's what we call this very pixelated, right? Each little box is going to be one color and one color only. Let me turn on the grid lines. So each little individual pixel has only got one value. It's going to be yellow or red or green or whatever it is. Now, when I zoom back, you can't even hardly see that. But when you look in close enough, it's exactly one value. I think I'm done in there for a while. So let's take a look at the code. And up at the top, I've got a bunch of comments, which I'm here to talk about. And it tells me that line 19, well, that line 19 is actually something a little bit different. I probably should have renumbered those. Let me get rid of these comments there. In fact, this is a broken comment. I'm going to get rid of that as well. There we go. This is a new concept. It's the idea that this is like a table of contents. There's the return type. Now, return type sounds funny, but it's just telling me what kind of data is going to come back when we're done. This is not something new, because int main is what tells you that when you're done, you're going to give back a value. So remember, we worked with this returning things like your favorite number. It's still, the type of data is still an integer. So we're going to return a value that's a whole number, is what we're saying here. Now, sample function name is probably a really bad example of a name, but excuse me. The reason I'm doing it is I can show you how to change the one function over and over again, and it'll do different things. I can bring this back up for a minute. There we go. So this sample function name here just basically says it's some name. You'll see that up here in the prototype. Where else are we going to see the name? We're going to see it somewhere, in fact, right here in the code. This is the call. This says go ahead and run the function, and on the way down there, bring these 2 values, F and S. What's this F and S? Reading the code above, let's start at the top. First thing I do is I say set up memory locations. Call them F and S. They're for the first and second number.
2 o'clock p.m., 68 degrees Fahrenheit.
I ask the user, give me the first number. Now, here's something you might not have seen before. I've used \n to go down a line. This one's going to go over a little bit. Okay, that's tabbing over. So if I run this, it's going to say first number, and it's going to tab over waiting for me to put in that first number. So it's not down a line, it's just over a little bit. That's happening from right here. That's where I am in the program. The next thing it's going to do is it's going to store that value in this variable called f. So let me get in here. I'm going to go in and I'm going to put, somebody give me a number to give it. 12. I see 12. I'm going to put 12 in there. 12 is in there. Now, if I look over on the right, I haven't pointed this out before, you can actually put in things to keep track of. I got a bunch of numbers now. So I've put in 12, and now I'm going to put in, see, I got another one here, 42. 12 and 42 are being passed down. And what I mean by passed down is this first number here, which is being printed by this line, and the second number, which is being passed down here, are being passed in. Let me grab the pen. This comes in order. Let's look at all the places we deal with f. F is a first number. We ask people for the first number. We store the number. We display what the first number is. We pass it down into the function. The second number comes slightly, I mean, it almost is the same. We set it up. We we put the value that they type on the keyboard in here. We kind of parrot back, all right, that's the number I got, and we pass it down. Now, whatever the sample function is, it's going to do something with them, and it's going to return the result of doing something with these two values. To actually see what's going on in sample function, we can't tell from the thing up there that was called the prototype. We can't tell from the call. We have to look at the details. So I'm going to scroll down, get back to my, I guess I need to clear the screen there. Alt-Z to clear the screen. There we go. There we go. So now this is the sample function that I've got down here. And in the sample function, most of this is just comments for you. It's telling you right now I'm in the function, and I've got the two values, and it prints out them. Now I want to point out something to you. V1 and V2 are different names. What? I thought they were F and S. Well, here's the deal. When you're passing values to somebody else, you don't know what they're going to call them. To you, it might be first and second number. To them, it could be value 1 and value 2. To somebody else, they might pass in a function like my current ammo and the amount in the clip I just picked up. But I need you to do something with them. I need them added together. Now, adding is a simple thing. You don't need a function to do it, but it might involve more with an inventory behind the scenes. All I need you to know is that the types of data and the order is the crucial part. What I mean by that is, draw another line here. The first one goes to the first one. So the first number, the value in there gets stored locally in this function in a holder or a variable called V1. And the second one gets put into this variable called V2. So whatever numbers get entered in main can be passed to other functions. You didn't see that in Lightbot. This is a new thing. So now that we have those values in here, we can do things with them. In this case, what's line 52 doing? It's adding the 2. It's returning the result of the 2. So it puts them together. It doesn't even store them. It just says, all right, here's what they are when they're put together. Now, I did notice somebody had a long number in here. And remember, anything beyond 5 characters is probably going to be too big for an integer. There's another way around it, but we're not going to worry about that right now. So even without all of these comments, which I can shorten up, I don't need these. These are here for you. They're called extra commentee. All right, all I really need in here is that return statement. That's the only thing that has to happen. The function body called sample function name right now is going to add them both. But if I wanted to copy this and paste it and set it up as a multiply, I could just change it like this. So the result is, so if I run this, I'm not really doing a call to add. I'm doing a call to whatever the sample function name is. So we'll grab the next two numbers here, 3 and 999. So those are multiplied together. And that's the result of multiplying 3 and 999. So I can change, one way to do this, just to see how it works, is I could change what's going on in here. I could change this to divide. Don't do a 0 with a divide unless you want to crash the system. Make sure your work's turned in first. So now if I run it, I'll do division. So let's do a division problem that we'll all be able to figure out pretty easily. Let's do 77, and let's divide that by 11 and see if we get 7. Result is 7. So this is showing you the idea of entering two numbers and passing them to a function and getting a result. What I want you to do is copy and paste the right parts so that you do it with add, subtract, multiply, and divide by passing values. Now, I could show that to you, but I want you to try it and ask questions. So I'm going to give you time to do that, and I'm going to hang back. And if you have a question, I might have you share your screen, and then we'll look at the details. But here's a speed run. Pay attention to what I'm going to do. Sample function. Right now, the way I left it off, what does it do down here? It does division, right? So if I want to just keep sample function for division, I can do that. So I can grab all of this whole line here. If I copy and paste this function prototype, I need one for every function I'm going to do. So I'm going to copy this, and I'm going to paste it here where it says divide. I'm going to paste it at the beginning. Because that's really what this thing's doing right now, is it's doing division. Up here, I need to have a function that's going to do adding. So I'm just going to call it adding. Subtract. I need another one that looks a lot like this. It's going to do subtract. I'll just call it subby. All you're doing is coming up with your own names. Now, they could be things like add, subtract, multiply, divide. It's just a name. As long as you can keep keep it straight. I would use short, meaningful names. I wouldn't say, all right, this function is called Bob, and Bob is going to do multiplication. That would not be a good choice because nobody's going to know what Bob does. It would work, but it's not a good idea. So I've got add, addy, subby, multi. Let's make it a Y so it's consistent. Addy, subby, multi. So these functions, and then sample function name, they're all bringing in two variables. So addy, subby, multi, and so all I would need to do to get these to work is to copy the parts down below and set them each up. These end in a semicolon. The ones down below are going to look just like it, but they're not going to have a semicolon. They're going to have the actual code. So sample function name is already set up. I don't need that one to be set up again. I'm just going to comment it out and leave it there. But addy, all it needs to do is add two numbers together. All I need in there, in my braces, is one command, return. What's the name of a variable down here? I'm going to call them A and B. All it needs to do. That's the only thing it needs to do in that area. That's addy. Subby is going to do something similar. No semicolon here. Put them inside of some curly braces. Just got to have one return statement. A minus B, semicolon. It's the end of that function. It's just doing one thing. Multi, same thing, really. It's no semicolon at the end. Open up the curly braces. So all I did is copy. I just came up with the names at the top with copy and paste. Then I went down to put in the details. Return A times B. This is really about you practicing. By the way, an extra semicolon like that wouldn't hurt it, but I'm just going to get rid of it for consistency. So now I've got multi, subby, addy, and I could actually, now I need to make sure that I've got the function call up here. So if I do these up here, I remember the names now. Addy. Subby. Multi. So I'm going to do add, subtract, multiply, and divide with all these numbers right in a row. So if I run this now, see how many error messages I introduce here. No, none. Let's do 5 and 300. So if I scroll up here, I can see that 5 and 300 go down. They add together, they're 305. Subtracted, it's minus 295. If I multiply them, it's 1500. And if I do a division, I get 0. Now I need to figure out the remainder. That part I'm leaving up to you to figure out. That's the scope of what I want you to do, and then turn that code in. Make sure you get your name at the top. Ask questions as they come up. You are released.